Okay, question number 48. Let M be a 2 by 2 symmetric matrix with integer entries. Then M is invertible if four options are given. 2 by 2 symmetric matrix. So we can start as let M be A, B, B, C. We are talking about invertible. Determinant of A, that is AC minus B square, should be non-zero. That gives me the invertibility of a matrix. Now, first option. The first column of M is the transpose of the second row of M. That says first column of M, that is AB, is the transpose of the second row, means like this. So it gives me A equals B equals C. When A, B, C all are equal, so determinant M will become 0, means it will not be invertible. Hence, it is wrong. Similarly, the second one, the second row of M is transpose of the first column of M, again gives me the same conclusion, so it is also not possible. Third, M is a diagonal matrix with non-zero entries in main diagonal. Non-zero entries in main diagonal means these two entries are necessarily 0. So determinant M will non-zero, means it is invertible. So option C is correct. The product of entries in the main diagonal of M is not the square of an integer. A, B, C all are integers. Since the product AC is the square of non-integer, means it cannot be B square. Means this term cannot be 0. So this option D is also correct. Hence C and D both are correct. Let's move to the next, that is question number 49. Okay, question number 49. Let A belongs to R and let F from R to R be given by fx equals x to the power 5 minus 5x plus A. Then we have to conclude about 3 or 1 real roots for which we need to find the value of A. Correct? x5 minus 5x plus A equals 0. We are talking about roots of this equation. So let's read it as A equals 5x minus x5 and assume a function gx 5x minus x5. Taking its derivative, we get, on substituting it 0, x equals plus minus 1. So points of maxima minima for gx we obtain 1 and minus 1. We can draw the graph of gx like this. This is the point x equals 1, this is the point x equals minus 1. When we put x equals 1, gx goes to 4, other one is minus 4. Now clearly, if we draw a line parallel to x-axis like this, it intersects the curve at 3 points if it is between minus 4 to 4. It intersects only 1 point if it is beyond this interval, either greater than 4 or less than minus 4. So the options are quite clear. First says 3 roots when A is greater than 4, it is false. Second says only 1 root when A is greater than 4, true. 3 roots when less than minus 4, false. Fourth is correct. So two options B and D are correct. Let's move to the next, that is 50th question. Okay, let's go for question number 50. Let M and N be two 3 by 3 matrices such that Mn equals Nm, means commutative. Further, if M is not equal to N square and M square equals N4, then we have to conclude about 4 options. So let's start this question as by multiplying these two matrices. It gives me M square plus Mn square minus N square M minus n4. Since mn equals nm, we can see these two are cancelled. We are left with m square minus n4, which is null matrix given to me, means product of these two is null. That gives me a straight conclusion that determinant of m plus n square is 0. Since it is non-null, it is non-null matrix, so it has to be a singular matrix, singular, or we can say it can also be a null. So determinant of m plus n square is necessarily 0. If we multiply by m, this is also 0. Hence the option 1 is correct. Option 3rd, that is C, is wrong. Second, there is a 3 by 3 non-zero matrix U such that product m square plus mn square into U is a zero matrix. Let's consider U m minus n square. It is known to me the product m minus n square and m plus n square is null. So I can see that the product of these two will become null if I take U as m minus n square. They are saying there is a 3 by 3 matrix. Not always, but there can be. So it is correct. Fourth, for a 3 by 3 matrix U, product equals the zero matrix, then U is 0. Not necessity, because U can be non-null. Even in that case, we can get zero matrix as we have seen in option B. Correct? So question number 50, correct options are A and B. Move to the next one.